In the late 1930s, as war clouds gathered over Europe, sleek German fighter aircraft broke through the sound barrier of its time, shattering world speed records and leaving engineers from London to Tokyo in awe. The Heinkel He 100 was faster, more elegant, and more technically advanced than anything else in the sky. It was a masterpiece of engineering, a fighter that promised to dominate the coming war. Yet despite all its brilliance, this aircraft never fired a shot in anger. The Luftwaffe rejected it. The factories that should have been churning out thousands of these machines stood silent. And in one of history's most audacious propaganda campaigns, the dozen aircraft that did exist were painted and repainted, photographed and rephotographed, to create the illusion of an entire Phantom Air Force. This is the story of the Heinkel He 100, the fastest fighter that never was, and the bitter rivalry, political intrigue, and technical gambles that conspired to keep it grounded. The story begins not with the He 100, but with defeat. In 1936, Ernst Heinkel, one of Germany's most respected aircraft designers, suffered a devastating blow. His company had submitted the He-112 fighter to compete for the contract to build the Luftwaffe's next-generation air superiority fighter. It was a beautiful aircraft, a gull-winged monoplane with clean lines and promising performance. But when the smoke cleared from the competition, it was Willy Messerschmitt's Bf 109 that won the day. The 109 was slightly faster, could turn a bit tighter, and though it had landing gear that looked like toothpicks and was notoriously difficult to handle on the ground, it had that edge the Luftwaffe was looking for. Heinkel's fighter was sent home, and only 100 or so would ever be built, most sold to foreign air forces desperate for modern aircraft. For Ernst Heinkel, this wasn't just a business setback. It was personal. Heinkel and Messerschmitt loathed each other with a passion that went beyond mere professional rivalry. Messerschmitt, in Heinkel's view, was nothing more than a glider builder who'd gotten lucky. Heinkel himself had designed hundreds of aircraft during World War I. He'd built seaplanes, bombers, reconnaissance aircraft. He was a true aviation pioneer, and here was this upstart Messerschmitt stealing what should have been his contract. But Heinkel wasn't the type to accept defeat gracefully. If Messerschmitt had won this round, Heinkel would design something so advanced, so revolutionary, that the Luftwaffe would have no choice but to recognize his genius. He would build a fighter that made the Bf 109 look like yesterday's news, and so, in his design offices, Heinkel assembled his team. The project that emerged was designated Project 1035, and it was ambitious from the very first sketch. The goal was simple but audacious: create a fighter faster than anything flying, with longer range than the competition, and wrapped in an airframe so aerodynamically clean it would slice through the air like a knife through water. The design team, led by the brilliant Günther brothers, obsessed over every detail. They knew that to beat the 109, they needed to squeeze every possible advantage from their design. The landing gear, including even the tail wheel, would retract completely into the fuselage, leaving no bumps or protrusions to create drag. The wings would be thin and elegant, mounted low on the fuselage. The cockpit would be fed seamlessly into the body, with a canopy that provided the pilot with excellent visibility in all directions. But the real innovation, the gamble that would either make or break the design, was the cooling system. Every piston engine generates enormous amounts of heat, and in 1938, the standard solution was a radiator, usually hung under the fuselage or built into the wing roots. These radiators worked, but they created drag, and drag was the enemy of speed. The Günther brothers had a different idea. What if, instead of using a conventional radiator, they could cool the engine using the skin of the aircraft itself? The concept was called evaporative cooling, and it was based on a principle of physics. When water turns to steam, it absorbs enormous amounts of heat. If you could spray the hot coolant from the engine into a chamber, let it flash into steam, and then condense that steam back into water by running it through pipes built into the wings and fuselage, you could cool the engine without any external radiator at all. It was brilliant in theory. The system would be completely drag-free, hidden inside the aircraft's skin. The He 100 would slip through the air with nothing to slow it down, but it was also risky. The system required no fewer than 22 small electric pumps to move the coolant through the network of pipes. Each pump had its own failure indicator light in the cockpit, because if even one fuel failed, the whole system could overheat. And if a single bullet punctured those pipes running through the wings, the cooling fluid would spray out, the engine would overheat in minutes, and the pilot would be forced to either bail out or crash land. Still, Heinkel believed it was worth the risk. Speed was everything in a fighter. The faster you were, the more you could choose when to engage and when to run. You could climb higher, strike harder, and survive longer. And the He 100, freed from the drag of a conventional radiator, would be the fastest fighter in the world. The first prototype, designated He 100 Vai-1, took to the air on January 22, 1938. From the very first flight, it was clear this aircraft was special. It was fast, responsive, and when the test pilots pushed the throttle forward, it accelerated like nothing they'd ever flown. But there were problems too. The evaporative cooling system was temperamental. Pumps failed. The engine overheated. During testing, flights were cut short again and again as warning lights flashed in the cockpit. And then there were the landing gear failures. The wide-set gear should have made the He 100 easier to land than the 109, but the struts were built thin and light to save weight, and they kept collapsing. 4 of the first 8 prototypes were damaged in landing accidents at various points during testing. The Luftwaffe test pilots who flew the aircraft weren't impressed. They complained about the high wing loading, which made the aircraft feel heavy and sluggish at low speeds, but Heinkel pressed on. Because despite the problems, the He 100 had one thing going for it that mattered more than anything else. It was blindingly fast. On February 26, 1939, test pilot General Ernst Udet took the He 100 Vai-2 up for a record attempt. Over a 100-kilometer closed circuit, he averaged 394.6 miles per hour, setting a new world record. It was a stunning achievement, and it put the He 100 on the map. The aviation world took notice. Here was a German fighter that could outrun anything in the sky. But Heinkel wasn't satisfied. He wanted more. He wanted a record so spectacular, so unassailable, that the Luftwaffe would be forced to put his aircraft into production. For the next record attempt, Heinkel's team took the He 100 Waf-8 and stripped it down for maximum speed. They clipped the wings to reduce span and drag. They removed unnecessary equipment. They optimized every surface, polishing the skin to a mirror finish. And on March 30th, 1939, test pilot Hans Dieterle climbed into the cockpit and took off. What happened next was aviation history. Flying a course barely longer than the time it takes to boil an egg, Dieterle pushed the He 100 to its absolute limits. The evaporative cooling system, designed for short bursts of maximum power, kept the engine from cooking itself during the approximately 3-minute flight. When Dieterle landed and the timers were checked, the result was staggering. 463.92 miles per hour. It was the fastest any piston-engine aircraft had ever flown, a record that would stand for years. The Fédération Aéronautique Internationale, the world's governing body for aviation records, ratified it as the new absolute world speed record for land planes. The previous record, set by an Italian seaplane in 1934, had been demolished. The He 100 was officially the fastest aircraft in the world. Surely, Heinkel thought, this would be enough. Surely the Luftwaffe would see what he'd accomplished and order his fighter into production. He already had plans for a production version, the AB-100D1, with a more conventional cooling system to address reliability concerns. The aircraft would still be fast, with a top speed around 400 miles per hour fully equipped. It had better range than the Bf 109, about 900 to 1,000 kilometers compared to 600. It could carry heavier armament. It was, by any objective measure, a superior aircraft. But the Luftwaffe said no. The official explanation was rationalization. Germany, the Reich Aviation Ministry announced, needed to consolidate its fighter production. The Bf 109 was already in mass production. Thousands were rolling off assembly lines. Switching to a new fighter would mean retooling factories, retraining workers, disrupting the supply chain. And there was another problem. The He 100 used the same engine as the 109, the Daimler-Benz DB601. This engine was already in short supply, with production barely keeping up with demand for the 109 and the Bf 110 twin-engine heavy fighter. If Heinkel wanted to build the He 100 with a different engine, the only option was the Junkers Jumo 211. But the early Jumo 211 didn't use a pressurized cooling system, which meant it was incompatible with the He 100's evaporative cooling design. Redesigning the aircraft for the Jumo would have taken time and money, and in the end the performance would have been worse than the Bf 109 anyway. So the official story was simple logistics. There weren't enough engines to go around. The 109 was good enough. The He-100, for all its speed and elegance, was surplus to requirements. But there were whispers of another reason. Politics. Willy Messerschmitt, whatever his technical abilities, was politically connected in a way Ernst Heinkel never was. Messerschmitt had cultivated relationships with key figures in the Nazi hierarchy. His factories were in Bavaria, in the south of Germany, away from the concentration of aviation firms on the northern coast. This geographic distribution appealed to the regime's leadership, who worried about having too much industrial capacity in one vulnerable region. More importantly, Messerschmitt had friends. Ernst Udet, the same pilot who'd flown the He-100 to its first record, was now head of the Luftwaffe's technical office, and he was a fan of Messerschmitt's designs. There were allegations, never proven but widely believed, that personal animosity played a role. That Messerschmitt used his political connections to ensure Heinkel's fighter never got the support it needed. Whether it was politics or logistics or simply bad timing, the result was the same. By mid-1939, it was clear the He-100 would never enter mass production. Heinkel had built approximately 25 aircraft in total, a mix of prototypes and pre-production models. 3 were sold to Japan, which was interested in using them as pattern aircraft for a domestic production line. 6 went to the Soviet Union, which wanted to study the evaporative cooling system for their own research. And 12 aircraft, the He-100D1 fighters with conventional radiators, remained at Heinkel's factory near Rostock in northern Germany. These 12 aircraft became Heinkel's private air force, flown by company test pilots and designated as factory defense fighters. It was a strange arrangement, a private company maintaining its own armed aircraft. But in the chaos of the early war years, stranger things were happening all over Germany. And then, someone had an idea. If the He-100 couldn't serve as a real weapon, perhaps it could serve as a psychological one. In late 1939, with war now underway, Joseph Goebbels' Reich Ministry of Public Enlightenment and Propaganda approached Heinkel with a proposal. The He-100 was already famous for its speed record. British intelligence knew about the aircraft and feared it. What if they could use those 12 leftover fighters to create the illusion of a much larger fleet? The plan was audacious and remarkably simple. Take the 12 He-100 or D1 aircraft and paint them with fictitious squadron markings. Photograph them at Heinkel's factory airfield, staging the images to look like operational Luftwaffe bases. Then repaint the aircraft with different markings and photograph them again, and again, and again. To anyone looking at the photographs, it would appear that dozens, perhaps hundreds of these superfighters were in service. They'd see aircraft with different unit insignia, different identification numbers, different paint schemes. They'd see them dispersed on airfields, being prepared for night missions, lined up ready for combat. And they'd assume Germany had deployed an entire fleet of the world's fastest fighter. Better still, the propaganda ministry decided to give the aircraft a new designation. They would call it Heinkel He 113. Never mind that only 12 tons aircraft existed, all of them He-100D1s. Never mind that not a single one would ever fly a combat mission. The He-113 would become one of the most successful deceptions of the early war. Heinkel employees posed as pilots and ground crew for the photographs. The aircraft were repainted between shoots, sometimes multiple times, to give the impression of greater numbers. The photographs were carefully staged. In some, the aircraft appeared to be preparing for a night fighter mission, despite lacking even a landing light. In others, they were supposedly photographed at bases in Denmark and Norway, though in reality all the images were likely taken at Rostock, with nothing in the backgrounds to definitively prove otherwise. These photographs were published in Der Adler, the official Luftwaffe magazine, and in newspapers across Germany. The stories accompanying them were dramatic. The He-113, readers were told, had proven itself in combat during the invasions of Denmark and Norway. It was faster than any Allied fighter, could outclimb anything in the sky, and was now entering service in squadron strength. The deception worked beyond anyone's wildest expectations. British intelligence took the bait completely. The Air Ministry included the Heinkel 113 on official recognition charts, listing its top speed as 390 miles per hour and noting it was in production and equipping frontline squadrons. A secret Royal Air Force intelligence report from 1940 concluded the aircraft represented a serious threat. Not everyone was fooled. Robert Sawnby, the senior air staff officer at RAF Bomber Command, looked at the photographs and noticed the He-113 had no visible space in the wings for guns or ammunition, a rather critical omission for a fighter. Another observant RAF officer pointed out the supposed night fighter version lacked even a landing light. But these skeptical voices were drowned out by the flood of intelligence suggesting the He-113 was real, and then Allied pilots started reporting encounters with it. During the Battle of France, a Hurricane pilot claimed to have shot down an He-113 over Dunkirk in May 1940. Several more were reported during the Battle of Britain in August and September. Air Chief Marshal Hugh Dowding, commander of RAF Fighter Command, noted that the He-113 had made its appearance in limited numbers and that its main attributes were high performance and sealing. American bomber crews joined in. After the United States entered the war and began flying missions over Europe, B-17 pilots reported being attacked by the mysterious superfighter. One pilot, after an encounter over the French coast in 1942, noted it was a very pretty plane. What had they actually seen? Most likely they'd misidentified Messerschmitt Bf 109s. The later models of the 109, with their refined lines and polished finishes, could look quite different from the earlier versions Allied pilots were used to seeing. In the confusion and adrenaline of combat, with aircraft flashing past at hundreds of miles per hour, it's easy to understand how a pilot might mistake a 109 for the feared 113 they'd been briefed about. The psychological effect was exactly what Goebbels had hoped for. Allied pilots went into combat worried they might encounter this supposedly superior aircraft. Intelligence analysts spent time and resources trying to track a 113 squadrons. And British leadership, particularly during the desperate days of the Battle of Britain, worried that Germany was holding back squadrons of super fighters for a decisive blow. Ironically, this may have actually helped the British. Air Marshal Dowding's fear that He-113s were about to be deployed contributed to his insistence on always holding back reserves, never committing his entire force to a single battle. This conservation of strength turned out to be one of the key factors in the RAF's eventual victory. The propaganda campaign continued for years. Reports of He-113 encounters persisted throughout 1941 and 42. There was even an erroneous intelligence report claiming one had been shot down at Pearl Harbor on December 7, 1941, thousands of miles from any actual He-100. Meanwhile, the real aircraft, all 12 of them, sat at Heinkel's factory, flown occasionally by test pilots on local defence patrols, but never seeing actual combat. No Allied bomber ever ventured far enough into northern Germany in the early war years to threaten Rostock, so Heinkel's private air force never fired its guns in anger. By 1943, the deception had run its course. Allied intelligence analysts, working with more concrete information from captured documents and interrogated prisoners, began to realise the He-113 was a phantom. Post-war examination of German records confirmed it. There were no production line serial numbers, no operational unit assignments, no combat loss reports. The He-113 had never existed as anything more than a propaganda exercise. But what of the real aircraft, the He-100 that had inspired the hoax? What happened to those dozen actual fighters sitting at Rostock? Their fate remains a mystery. None of the He-100 aircraft, not the prototypes, not the Japanese purchases, not the Soviet acquisitions, and not Heinkel's factory defenders, are known to have survived the war. Whether they were destroyed in bombing raids, scrapped for materials, or simply abandoned and left to rust, we don't know. Not a single example exists in any museum anywhere in the world. Even the blueprints were lost, destroyed in a bombing raid on Heinkel's offices. So we're left with questions. What if the Luftwaffe had put the He-100 into production? Would it have made a difference in the war? The answer is complicated. The He-100D1, with its conventional cooling system, was certainly a capable aircraft. Its top speed of around 400 miles per hour was excellent for 1939. Its range of 900 to 1,000 kilometers was superior to the Bf 109, and its clean low-drag airframe meant it had room for development, potential for improved engines and heavier armament. But it also had limitations. Complex cooling system, even in its simplified form, was difficult to maintain under field conditions. The landing gear remained prone to failures throughout testing. And perhaps most critically, by the time a production version would have been ready, the war had already begun, and Germany needed fighters immediately, not after months of factory retooling and production delays. The Focke-Wulf 190, which entered service in 1941, proved to be the second great fighter Germany needed. Unlike the He-100, it used a radial engine, the BMW 801, which meant it didn't compete for the precious DB601 engines. Its air-cooled engine was simpler to maintain and less vulnerable to battle damage than liquid-cooled designs, and Kurt Tank's design team had learned from the mistakes of others, creating an aircraft that was both high-performing and practical for mass production. Could the He 100 have filled the role the 190 eventually took? Possibly, but it would have required solving the cooling system reliability issues, addressing the landing gear problems, and most importantly, finding an alternative engine that didn't compete with Bf 109 production. It's not clear Heinkel ever could have made those changes in time to matter. There's also the human element. Ernst Heinkel, for all his genius, was not as politically adept as Willy Messerschmitt. In the Byzantine world of Nazi Germany's military-industrial complex, political connections mattered as much as technical merit. Heinkel's outspoken nature and his ongoing feuds with key figures in the Luftwaffe hierarchy didn't help his cause. By 1942, Goering had seized control of Heinkel's company, forcing Ernst Heinkel to sell controlling interest and effectively sidelining him from his own firm. Heinkel moved to Vienna and opened a new design bureau, continuing to work on aircraft projects throughout the war. His He-177 bomber, plagued with engine problems from an ill-advised coupled power plant design, became one of the Luftwaffe's greatest failures. His He-219 night fighter was brilliant but produced only in limited numbers, again due to political interference. And his He-280 twin jet fighter, which flew before the Messerschmitt Me-262 and showed great promise, was passed over in favour of Messerschmitt's design. The pattern repeated throughout the war. Heinkel would create something innovative, even revolutionary, and politics would prevent it from reaching its potential. Whether this was justified based on practical manufacturing and logistical concerns, or whether it was the result of personal animosity and political manoeuvring depends on who you ask. What we do know is this: the Heinkel He 100 was one of the fastest fighters of its era. It set records that stood for years. It demonstrated innovations in aerodynamics and cooling systems that influenced designs from Japan to the Soviet Union. The Kawasaki Ki 61 and Yakovlev Yak 9 both owed debts to Heinkel's work, even if neither adopted the troublesome evaporative cooling system. But the He 100 never got its chance to prove itself in combat. Instead, it became a footnote, remembered more for the propaganda campaign it inspired than for its actual capabilities. The mythical He-113 achieved more fame than the real He-100 ever could, a testament to the power of perception in warfare. After the war, Heinkel, like Messerschmitt, was prohibited from manufacturing aircraft. He turned to bicycles and motor scooters for a time, building the Heinkel Cabine bubble car that competed with Messerschmitt's own microcar offerings. Even in peacetime, it seemed, the two rivals couldn't escape each other. By the mid-1950s, restrictions had eased enough for Heinkel to return to aviation, working with other companies and eventually helping to build Lockheed F-104 starfighters for the West German Luftwaffe. In 1958, in a twist of fate that must have amused both men, Heinkel joined forces with his old rival Messerschmitt in a new venture to manufacture anti-aircraft missiles and modern jet aircraft. The day after this partnership was announced, Ernst Heinkel died. He was 69 years old. Today, aviation historians look back at the He 100 with a mixture of admiration and frustration. It represents what might have been, a fighter that had the potential to be truly exceptional but was undone by a combination of technical challenges, political machinations, and terrible timing. The evaporative cooling system, for all its promise, was simply too complex and vulnerable for combat use. Every nation that experimented with the technology eventually abandoned it in favour of more conventional solutions. The British used surface radiators on racing seaplanes, but never on combat aircraft. The Soviets studied it extensively, but never put it into production. Even Heinkel himself eventually gave up on it, fitting conventional radiators to later versions of his designs. And yet, the He-100's low-drag airframe design influenced countless aircraft that came after it. Its sleek lines and attention to aerodynamic detail set a standard that other designers aspired to match. The lessons learned from its development, both the successes and the failures, informed the next generation of high-performance fighters. Perhaps the greatest irony is that the aircraft's most successful mission was one it never flew. As the fictitious He-113 photographed and rephotographed, painted and repainted, it convinced Allied intelligence of German air superiority that didn't exist. It tied up resources, created anxiety among Allied pilots, and contributed to strategic decisions based on a threat that was nothing more than smoke and mirrors. 12 aircraft, a paint booth, and a camera. That's all it took to create one of World War II's most successful deceptions, the legacy of the Heinkel. He 100 is complicated. It was a triumph of engineering that never reached its potential, a record breaker that never saw combat, a phantom that was more famous in fiction than in fact. None survive today. The metal that once flew faster than any fighter in the world was likely melted down for scrap, or rust somewhere in a forgotten corner of what was once the Third Reich. The blueprints that could have told us exactly how it was built were destroyed in the chaos of war. All we have left are photographs, performance specifications, and the memories of test pilots long since past. But the story endures. It's a reminder that in war, as in peace, innovation alone is not enough. You need timing, you need political support, you need luck. The He 100 had the innovation but lacked everything else it needed to succeed. So the next time you hear about a revolutionary new weapon that never quite made it to production, remember the He 100. Remember that sometimes the fastest, most advanced, most innovative solution still isn't the right answer. And remember that in the high-stakes world of military procurement, politics can matter just as much as performance. The Heinkel He 100, the fastest fighter that never was, the phantom that fooled a generation, the masterpiece that history forgot.